The engine that could take us to Mars in 30 days. The dawn of plasma propulsion. Imagine waking up one morning to the news that reaching Mars, once a dream reserved for science fiction, could soon take only 30 days instead of 7 long months. No cryosleep, no decades of waiting for the perfect launch window. Just a blazing journey through the void of space, powered not by fire and fuel, but by plasma, the fourth state of matter. This is not a fantasy anymore. It's real science, unfolding right now in the laboratories of the United States. In late 2025, a breakthrough announcement shook the world of space exploration. A team of American physicists, engineers, and propulsion scientists unveiled a new kind of plasma engine that could potentially cut the travel time to Mars by more than 80%. Their creation, sleek, metallic, and humming with contained lightning, has the potential to redefine how humanity explores the cosmos. The birth of a revolution in propulsion. For decades, NASA and private companies like SpaceX and Blue Origin have chased the dream of faster, more efficient space travel. Traditional chemical rockets, the kind that powered the Apollo missions and even the modern Falcon Heavy, burn through massive amounts of fuel to escape Earth's gravity. But once in space, they become painfully inefficient. The reason is simple. Chemical propulsion relies on brute force. It's like trying to cross the ocean in a speedboat with limited fuel. You can go fast, but not far. That's where plasma propulsion changes everything. Plasma, often called the fourth state of matter, is an electrically charged gas made up of ions and electrons. It's the same substance found in lightning, the sun, and distant stars. Scientists have long theorized that if we could harness plasma efficiently, we could generate thrust without relying on combustion. The challenge was always control, keeping that superheated, unpredictable plasma stable and directed. In early experiments, plasma engines produced only a fraction of the power needed for interplanetary missions. But now, something extraordinary has happened. The discovery that changed everything. At the Princeton Plasma Physics Laboratory, PPPL, a research center that's been quietly shaping the future of energy, scientists have been experimenting with magnetoplasma dynamic thrusters and a newer technology known as VASIMIR, or Variable Specific Impulse Magnetoplasma Rocket. The latest generation of these engines uses magnetic fields to heat and accelerate plasma to unimaginable speeds, up to 100,000 miles per hour or more. Dr. Franklin Chang Diaz, a former NASA astronaut and physicist who has championed plasma propulsion for decades, described the breakthrough simply: "We've gone from theory to control. We can now generate, contain, and direct plasma with precision. This could take us to Mars in a month, or to the outer planets in a year." The principle is astonishingly elegant. Instead of igniting chemical fuel, the plasma engine uses radio waves and magnetic fields to ionize a gas, typically argon or xenon, into plasma. The charged particles are then accelerated through magnetic channels and expelled from the back of the engine at extreme velocity, producing continuous thrust. Unlike chemical rockets, which burn hard and fast for a few minutes, plasma engines can thrust continuously for months, sipping fuel while accelerating gradually. In deep space, that constant acceleration builds up tremendous speed, turning long journeys into astonishingly short ones. 30 days to Mars, how it works. Here's where the numbers become mind-bending. A chemical rocket like NASA's SLS or SpaceX's Starship can reach Mars in around 7 to 9 months, depending on planetary alignment. A plasma-powered spacecraft, on the other hand, could make the journey in just 30 to 45 days, all while using less fuel. The secret lies in specific impulse, a measure of how efficiently an engine uses fuel. Chemical rockets typically achieve around 450 seconds of specific impulse. Plasma engines? Over 5,000 seconds, sometimes even 10,000 seconds. That means they can extract nearly 20 times more thrust from the same amount of propellant. But speed isn't the only benefit. Faster travel reduces exposure to cosmic radiation, solar flares, and microgravity, major threats to astronaut health. It also means quicker cargo delivery, faster emergency response for Mars colonies, and even the potential for interplanetary tourism one day. A new era for NASA and the U.S. space industry. NASA has already taken notice. In collaboration with Ad Astra rocket company, led by Dr. Chang Diaz, and Helix Space, a U.S. startup pioneering compact plasma reactors, the agency has begun early-stage testing of plasma propulsion systems for future deep space missions. A prototype engine known as VX200SS recently completed a 100-hour continuous test, achieving stable plasma thrust without overheating. Engineers reported that the system could, in theory, operate for years, something chemical rockets could never dream of. Meanwhile, the U.S. Department of Defense is quietly interested too. A plasma propulsion system could enable rapid maneuvering satellites, deep space probes, and even long-range defense systems capable of reaching anywhere in the solar system at unprecedented speed. The physics behind the magic. Plasma propulsion may sound like science fiction, but it's deeply grounded in physics. Every plasma engine must solve three fundamental challenges. Containment. Plasma can reach temperatures of over 1,000,000 degrees Fahrenheit. Only magnetic fields, not physical materials, can contain it. Power supply. These engines require enormous electrical power, usually generated from solar arrays or compact nuclear reactors. Control. The plasma's magnetic and electric properties must be precisely tuned to prevent instability or energy loss. The recent breakthroughs involve magnetic nozzle design and superconducting coils that make control much more stable. With advanced cooling systems and new power sources like miniaturized nuclear fission reactors, plasma propulsion is finally entering the realm of practicality. From the sun to the stars. What makes this discovery even more thrilling is its long-term implication. Plasma propulsion could eventually take us far beyond Mars, to Jupiter, Saturn, and even the edge of our solar system. Missions that would once take decades could happen within a few years. Scientists have already imagined robotic explorers using plasma engines to chase comets, visit icy moons, or deploy telescopes to interstellar space. Imagine sending a probe to Pluto and getting data back in months, not decades. Imagine cargo ships continuously shuttling between Earth and Mars, building the foundation of a multi-planet civilization. Challenges ahead. Of course, this isn't an easy road. The biggest challenge remains energy. Plasma engines demand vast amounts of electricity, more than solar panels can currently provide for long missions. That's why researchers are exploring nuclear electric propulsion, combining compact fission reactors with plasma engines to create the ultimate deep space drive. There are also concerns about scaling the system safely for crewed missions. Plasma thrusters produce relatively low initial thrust, so they can't lift off from Earth directly. They must be launched into orbit first, then fired in the vacuum of space. Still, these are engineering problems, not impossibilities. And with each test, humanity gets closer to solving them. The dawn of a new space age. For the first time since the Saturn V rocket carried humans to the moon, a propulsion technology has appeared that could truly change everything. Plasma engines represent more than a faster way to travel. They symbolize humanity's next great leap. Dr. Chang Diaz once said in an interview, "When we reach Mars in 30 days, it won't just be a technological milestone, it will be a spiritual one. We'll become a spacefaring species, not just visiting, but staying." If that vision comes true, future generations might look back on 2025 as the year it all began. when the lightning of the stars was finally captured and turned into an engine for the human spirit. From the deserts of New Mexico to the labs of Princeton, from NASA's testing facilities to the dreams of children looking up at the night sky, a new power hums quietly into existence. It doesn't roar like a rocket. It sings in electromagnetic whispers, and with it, humanity prepares to leave its cradle, not in centuries, but within our lifetime. The plasma engine has arrived. The stars are calling, and this time we might just have the means to answer.